Students, in the previous class we have discussed about triangular law of vector addition. In today's class we will discuss about parallelogram law of vector addition. Now this law states that if two vectors are represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, then the resultant is represented in magnitude and direction by the diagonal of parallelogram drawn from the same point. So over here there are two vectors drawn from the same point, this point vector B and A. So these are the two sides of a parallelogram. So we draw two more sides of a parallelogram. Suppose this side represents A. This side and this side of a parallelogram will be equal, if you know that, and the other two sides of a parallelogram will also be equal. This is equal to B. Now according to this rule, the resultant vector will be the diagonal. So this is the diagonal, which is R. Okay, so for this one the derivation is not there, so I'll just write the formula. It's the same as what we have done for triangular law, that is a square plus b square plus 2ab cos theta. This is the magnitude of a vector, magnitude of the resultant vector. The direction is given by tan alpha, which is tan alpha is equals to b sin theta divided by a plus b cos theta. Now these two formulas are same formula which we have derived for the triangular law, so derivation is not required, just the formula is there. Now there are special cases. Okay, first there are special cases. First one is when two vectors are in same direction. So when two vector A, B becomes in same direction, then the angle over here will be 0 degree. So in this situation, what will be R and tan alpha, that is magnitude and direction, that is what we are supposed to find. So if theta is 0, then R is equals to, in place of cos theta I'm writing 0, a square plus b square plus 2ab cos 0. Now cos 0 is 1, cos 0 degree is 1. So if this becomes 1, then this is what we are left with, under root a square plus b square plus 2ab. So ultimately that is a square plus b square plus 2ab. This is actually a plus b whole square. This is the formula for a plus b whole square. So it is a plus b whole square. So if we take this out of the root, we can write a plus b. So when theta is 0 degree, the magnitude will be a plus b. Now the direction, that is tan alpha, which is b sine, in place of theta we are writing 0, a plus b cos 0. Now sine 0 is 0, so b into 0, a plus, this is 1. So if this is 0, the whole part becomes 0. So tan alpha is 0 degree. So it means that the angle between the two vectors, that is a and b, is 0 degree. There is no angle, that means they are moving in the same direction. This is the first case. Now in second case, that is number 2, when two vectors are at right angle. So suppose this is vector B and this is vector A. Right angle means angle theta is 90 degrees. So in this situation theta is 90 degree. So your R is equals to, I'm just writing the formula directly, plus a square plus b square plus 2ab cos 90 degree. So cos 90 degree is 0. Okay, cos 90 is 0, so this whole part becomes 0. So what are we left with is a square plus b square. R is under root a square plus b square. So this cannot be taken out of this root. So your magnitude remains under root a square plus b square. Now the direction is tan alpha is equals to b sine 90 degree. I am not writing the formula, I hope you know that, just writing the values. So in place of theta I have written 90 degree. Cos 90 is 1, so this becomes b. Cos 90 is 1, simply b into 1 is b. A plus b. Cos 90 is 0, so b into 0. So this part becomes 0. We are left with b by a. So tan alpha is b by a. This is the direction. Now the third situation. When two vectors are in opposite direction, suppose this is vector b, this is vector a, are in opposite direction. So angle over here theta is 180 degree. Okay, so theta is 180 degree. In this case, r is equals to under root a square plus b square plus 2ab cos 180 degree. Cos 180 degree is minus 1 and sin 180 degree is 0. So this is minus 1. It becomes a square plus b square. If this is minus 1, then this becomes minus 2ab. So this is the formula of a minus b whole square under root. Okay, which is equals to, if you take it out of the root, it becomes a minus b. Okay, only a minus b. So your r is a minus b. Now the direction. For direction, formula is tan alpha is equals to b sine 180 degree divided by a plus b cos 180 degree. Now b sine 180 degree is 0, so ultimately this becomes 0. Tan alpha is 0 or 180 degree. Now thus the magnitude of the resultant vector is equal to the difference of the magnitude of the two vectors and acts in the direction of the bigger vector. So in this situation where it is 180 degree, okay, where two vectors are in opposite direction, a and b, so ultimately the resultant vector has to be in one particular direction. So in which direction it will act, it will be there. So ultimately whichever vector is greater, okay, if a is greater, then the resultant vector r will be in this particular direction. If b is greater, then the resultant vector will be in the direction of b. So from all these three cases, what we can conclude is the magnitude of the resultant vector of two vectors is maximum, okay, when they are in the same direction. Okay, when they are in the same direction means in this situation, that is in the first case, that is when theta is 0 degree, when theta is 0 degree, then the resultant vector is maximum. Okay, the resultant vector is, this is maximum. When theta is 90 degree, okay, when theta is 90 degree, it is not minimum, but when theta is 180 degree, this r is minimum. Okay, this is the rule for addition of vector, that is how do we add vectors using this formula, that is r, which is the resultant vector, and magnitude, that is tan alpha. Another important topic is unit vector. A unit vector whose magnitude is unity is called a unit vector, whose magnitude is unity or 1. Okay, the value is 1 or unity is called a unit vector. Suppose we consider unit vector as a. Okay, a is a unit vector whose magnitude is, whose a is the magnitude, and the direction is represented by a cap. Okay, a cap gives the direction. So any alphabet with a cap, this cap over here means the direction, without the arrow means the magnitude. So a vector, a unit vector is a composition of magnitude and direction. So this is one of the important formula. Okay, so any vector in the direction of unit vector may be written as the product of unit vector and a scalar magnitude of that vector. Suppose if there are three axes, x, y, and z. So a vector, if you want to show a vector in this direction, okay, in the direction of x, then that will be represented by I cap. The vector in the direction of y will be j cap, and the direction of z will be k cap. So if it's in the direction of x, it is represented by I cap, y it is represented by j cap, and k it is z it is represented by k cap. So this is very important term you need to remember. This notations are known as orthogonal unit vector. Okay, these are known as orthogonal unit vector. This gives, anything with the cap gives the direction. So for x it is I, for y it is j, and for z it is k. One of the important topic in vector is resolution of vectors. Resolution means breaking. Okay, now when this is required in many topics in physics. For class 12 also this is very important. Why this is important? Every term in physics is represented as vector quantity. Okay, maximum terms are represented as vectors, but all the time we don't know the direction of the vectors. So in order to find its parallel or perpendicular direction, we break a vector. Suppose there is this vector A. Now this vector is in a random direction. Okay, random direction. So if you want to know the value of this vector, first of all we need to know its parallel and perpendicular value. So you draw a line over here. This is the base. Okay, we draw another line perpendicular. So this is A along x-axis, this is A along y-axis. This is what we have done, is we are breaking this vector A into two parts, that is ax and ay. So A is actually ax plus ay. This is exactly opposite of that of addition of vectors. While adding a vector, we add these two vectors and this line gives the resultant. But when we resolve a vector, when we break a vector, we break this into two parts, that is ax plus ay. Now to find the value of ax and ay, ultimately we have to know this value to find the ultimate value of a. So we make this angle as theta. We draw a perpendicular over here. We draw a perpendicular line this side. Let us write this as R P O. Okay, and another line also we draw from this side. So this side is Q. In vector notation we can write this as ax I cap, because x is along I direction or x-axis. So this can be written as ay j cap. Ultimately vector A is this. This is in a vector notation. Okay, this is vector notation. Now to find the value of ax and ay. If you look this right over here, this is a triangle. So in triangle ROP, okay, ROP. Now whenever an angle is attached with the line, this becomes theta with attached with the side. This is the base, this is the hypotenuse, this is the perpendicular. So any side attached with the base is what we find, first of all, cos theta, because cos theta is base by hypotenuse. So if you want to find the base side, okay, this is a simple logic. If you want to find a base, this is the base side. So we want to find ax, which is the base. So if you want to find the base side, we write cos theta. Suppose if you want to find this side, that is perpendicular, then we write sin theta, because sin theta is perpendicular by hypotenuse. So now in angle ROP, cos theta is equals to base. Base is ax. Hypotenuse is this side, that is your a. So ultimately from this what you can write is ax is equals to a into cos theta. By just simply cross multiplication, your ax becomes a cos theta. Similarly, in this diagram, this side is ax. This looks like a parallelogram, so this side will also be your ax. If this side is ay, this side will also be equal to ay. So when you want to find ay, simply you can consider the perpendicular side. So again, in triangle ROP, sin theta is equals to, sin theta is perpendicular divided by hypotenuse. So look over here, perpendicular is ay, perpendicular is ay, hypotenuse is again a, sin theta. So ay is equals to, take this a the other side, a into sin theta. This is ay, this is ax. So if you want to find ay and ax, that is the base side and the hypotenuse side, this is how you find. Now ultimately a is equals to ax plus ay, which is equals to a cos theta plus a sin theta. So this is how you find the resultant vector by the way of breaking the vector. By breaking the vector, this is how you find the resultant vector. Or what you can do is, if you look at this triangle over here, this looks like a right angle triangle. Okay, this looks like a right angle triangle. So it is a square is equals to hypotenuse square is equals to base square, which is ax plus perpendicular square. So a is under root ax square plus ay square. This is also how you can find the value of a. The angle, that is tan theta, is equals to, now to find the angle tan theta, look at this triangle over here. Tan theta is perpendicular divided by base. Okay, so your perpendicular is ay and base is ax. So tan theta will be ay by ax. Or theta is equals to, if you take tan other side, I hope you haven't seen this before, we write tan inverse. Okay, if tan is this side, then if you want to take this other side, then we can write tan inverse, ay by ax. This is how you find the direction. This is a way of resolution of vector. That means we break one single vector into two parts and find the individual part and add ultimately to find this vector. So this is also how we add a vector or break a vector. This is highly required in physics to find the parallel or the perpendicular side. So from here what we have understood is, any side attached with theta is always the cos theta side. Any side which is not attached to theta, which is opposite to that of the theta, this side will be sin theta side. So from next time onward, if you see this type of a triangle where you don't know this side, then ax will be, this side will be a cos theta and this side will be a sin theta. This is by resolution of vectors. If I write directly these values, do not get confused. This is how I get the values. Okay, I think this much for today. We'll continue in the next class. Thank you.